Hello everyone, welcome back to my YouTube channel. Ndana time ndisina kumboposta my videos O level physics. I'm aware I'm supposed to finish kinematics, then also see the total direction after this. So kinematics already I have 2 videos uploaded, part 1 and part 2. So today we'll be looking at part 3. Then part 4 will be more like a revision. Yateti chingoweka ma questions under the subject kinematics. Yateti chingowatenda kuma questions anenge ari under this topic from start to finish. But for today we'll be looking at motion under gravity. So the reason why I wasn't uploading penny yangu yandinoshandisa yakafa for my tablet, so I wasn't able to record. So and I had to place an order kuti iuye so that I could resume. So pakuzo resume ndakazongotanga neku uploada imwe content, but yeah, it's good to be back. So today we'll be looking at motion under gravity, and these are the 5 objectives, learning objectives that inazo. So in this particular lesson we want to learn about free fall. So we need to define free fall clearly so that you have a solid understanding of what free fall is. Also need to explain acceleration due to gravity. Also going to look at terminal velocity. Then we're going also to look at interpretation and drawing my velocity time graphs and check with an emotion under gravity. Then also we are going to attempt a few questions, I think 1 or 2 exam style questions, and how we can approach them. So if you have any questions concerning the content that I'm posting, feel free to contact me on the details akaitwa highlighted in the video description, or even to just comment in the comment section. And also don't forget to like, comment, share and subscribe. Guys, this is just voluntary work. I'm not a teacher by profession, but I just have a passion of helping you out because I feel there is a need. Some may not be able to afford my extra lessons, so akakwanisa kuwana access to Wi-Fi, then they have access to my videos. So it's just out of the passion to help. So feel free to share my content with other students. Share the link in your groups so that people can be able to access the content. The content and learn a few things from it. So now let us go into today's lesson. So today's lesson we are looking at motion under gravity, and for starters we need to define free fall. So free fall by definition is the motion of an object when gravity is the only force acting on it. Let's write that down. So trukuti isusu kana object yedu iri in a moment yekuti iri kuita undergo motion, and the force iri kukonzeresa that motion is gravitational force. That kind of motion is classified as a free fall. Kana chinhu chichifamba zvichikonzerwa chete negravitational force, kana kuti gravitational force ndiyo yega force iri kushanda pachiri chinhu ichocho, motion iyoyo inodanidzwa kunzi free fall. So zvazvinoreva ndezvekuti this means number 1, no air resistance. So ukatora peni yako wakaibata handitika ukairegedza kuti idonhe kudai, kana ikadonha kudaro so handitika tobva tati exclusive, not including air resistance, the force iri kuacta pairi it's gravitational force, then that is free fall. naika. So no air resistance, no pushing or pulling forces. Number 3, only the Earth's gravitational pull acts on the object. Right. Only the Earth's gravitational pull acts on the object. So what happens is free fall is not something that can actually happen in a real world, because the real world in the presence of air resistance kune also my external forces akasiyana siyana. So the only way yatokwanisa kuexperience free fall practically is when the situation or maybe the environment yatiri is a vacuum, because mu vacuum musina air, which means amuna air resistance. So actually, practically speaking, in a real world scenario, free fall does not exist. Free fall inongova an idealized situation, exist only in a vacuum. Mune space is not air, which means amuna air resistance or any other external forces that can act on the body. So free fall, by definition, tataura kuti emotion ye object when gravity is the only force acting on it. So gravity, also known as the force of gravity, and it right. So now tiri papo, there is something I would want us to take note of. Number 1, free falling objects accelerate at a constant rate. My free falling objects, so apana force inenge ichiacta paari iri kuopposa their motion, those bodies, so anenge achingo accelerate at a constant rate. Number 2, the acceleration due to gravity is approximately 10 meters per second squared. So acceleration due to gravity is approximately 10 meters per second. So the most accurate the most accurate would be 9.81 meters per second squared, but yeah, 10 is acceptable for your stage yamuri kudzidza nayo physics. Right, let us move. Then under free fall, objects reach the earth at the same time, irrespective of their mass. Ma object anosvika on earth at the same time. So if they are dropped at the same height, totora football, totora kana dombo, tikazviregedza zvese zviri 2 from the same height. This is a building, right? So this is a stone, this is a football. Tiri kuti isusu kana zvese zvichibva pasame height. Alright, let's say this is 100 meters. Tikazvidropa in a free fall scenario, despite kusiyana handitika kusiyana kwemamasses awo, ngatiti ichi m1 ichi m2, despite kusiyana kwemamasses awo, kuti iri ibhora riri dombo zvakatosiyana mamasses acho, kana iri same height yatiri kudropa for in a free fall situation, zvinofanira kusvikirana at the same time, because zvinodzika neacceleration yakafanana, because tati isusu acceleration due to gravity for bodies idzodzidzi inenge iri 9.81 kana kuti 10, right? So now let us talk about falling objects. So pane zvinhu tu zvandoda kuti muzive about falling objects in general. Now this is in a real world kana kuti practical scenario zvinoitoitika. Apa tatichitaura about an ideal scenario, ingori practical only in a vacuum, that is free fall. Free fall you can only happen in a vacuum because ndo musina air resistance or other external forces. So it's a ideal situation. But talking about practical situations, as zvinotoitika in day-to-day lives, toda kuti muzive kuti falling objects are acted on by two types of forces. Number one, they are acted on by the weight of the object. Number two, they are acted on by air resistance. Air resistance inoenda opposite the direction the motion. So ngatiti isusu tiri pamusoro pebuilding, toregedzera dombo richidzika, because dombo iri rine weight, handiti rinotanga kudropa richidzika pasi. So direction motion yedombo iri is downwards, but air resistance inenge ichienda opposite, which is upwards. So air resistance is always in opposition to the direction of the motion of the body which is falling. So the weight of the object, we need to know that this is our object, and it. So the weight of the object, because weight is a force. One thing you should know, weight is a force. Weight is a force. What kind of a force? Is a force acting on a body due to gravity. Right? If force iri kuacta pane body zvichikonzerwa negravity. So gravitational force exist. It's a force that exists between two bodies. So kana munhu achinzi ajamba, then gravity yanga ichimudhonza, paipo ndojamba chinokudhonza paipai gravitational pull iri kubva from the body, the other body, which is the earth in this case. So earth newe pakati penyu pane gravitational force apabata. So gravitational pull inenge ichibva kuearth ndo inenge ichikudhonza iwewe, handitika. So weight becomes weight yawinayo iwewe is a force iri kuacta on iwewe zvichikonzerwa negravitational pull iri kubva kuearth, naika. So to be grounded, tikuti isusu this is a force that is acting downwards, always caused by the object's mass being pulled by the earth's gravitational field, naika. So ndizo mafambire azvinenge zvichiita iwayaya. Then for air resistance is more like frictional force. So this is gravity, handiti. But air resistance now more like friction, you know friction opposes motion every time. So panapa air resistance, it's a frictional force naika inenge ichiopposa opposite direction to the movement of the object. So the act of falling of objects can be categorized into 3 stages before it hits the ground. So object yedu ichidonha kudai so zvinoitika kwairi tinogona kuzviisa mumipanda mitatu totanga kutsanangura one by one for each stage. So pekutanga tanga at the start, pekutanga tanga the object accelerates downwards because of its weight. Take note of this. The object accelerates downwards because of its weight, right? So at the start, there is no air resistance. There is a resultant force acting downwards. Tanga. But now, as it gains speed, so at the start, body yedu isati yatotanga kutofamba inenge iri pa0 velocity, but the moment yatinoirelease inotanga kuaccelerate downwards, ichienda. So at that point where t is equals to 0, time is equals to 0, there is no air resistance acting on it because it is stationary. Air resistance only comes into play the moment yatinoirelease yakutanga kutofamba. This is the physics of falling bodies. So as it gains speed, stage number 2, speed, and it don't mind my handwriting. The object's weight stays the same. Right? Object's weight stays the same, but the air resistance increases. But the air resistance increase. So there is a resultant force acting downwards. So look at it this way. Body iri kudzika due to W, which is its weight. But also because of air resistance, tane force iri kuenda upwards. So resultant force, because are going in the different directions, F resultant, FR, is equal to weight minus air resistance. This becomes the resultant force. Unlike pekutanga up, per stage number 1. Per stage number 1, acceleration yanga isati yatombotanga. Tatiri pa t is equal to 0. As long as t is equal to 0, then atina is kuitika. Because remember, isusu acceleration is the rate of change of velocity, kana kuti change of velocity with respect to time. So kana time iri 0, atina acceleration natikutaranira. We can only talk about acceleration when it's released. So the object accelerates downwards because of its weight, because this is after release. So if you check now, the F resultant is equal to weight minus 0, because air resistance is hapana. Alright, then number 3, pane kuti body nenge ichitravela at a steady speed. Eventually, the object's weight is balanced by the air resistance. There is no resultant force and the object reaches a steady speed called the terminal velocity. So what's happening now is tareleasa body yedu isusu kuti idzike, iri kukonzereswa kudzika kwayo neweight, but there is also air resistance. So you would realize that air resistance increase as the acceleration your body increases painenge ichidzika. So zvinotozosvika pekuti air resistance iyi inenge yamecha weight iyi, such that tikati f resultant yedu ye weight minus air resistance inobva yaita 0. Ikaita 0, what it means, there is no more acceleration, no acceleration anymore, inobva yapera. Right? So let's explain this in a way I'm not gonna understand. Tareleasa body yedu yanga iri at t is equals to 0, time is equal to 0, velocity was at 0, but pataireleasa isusu, because of its weight yatanga kuaccelerate, ichiaccelerate, but as it was accelerating, also take note kuti air resistance, which is a frictional force, act against that body, was also increasing, yanga ichi-increase out. So zvinotozosvika pekuti air resistance inomecha the weight of the body, and they can measure the weight of the body. What then it means is f resultant yedu becomes 0, and when it becomes 0, velocity inenge yakufamba nebody yoyo inenge yakunzi terminal velocity. Right, so let's define terminal velocity. Kuti chi. So it is a constant velocity. And terminal velocity is a constant velocity, or rather you can call it constant speed, and reached by a falling object, and when air resistance becomes equal to its weight. So it stops accelerating. So body yedu at start iri kudzika ichiaccelerate, inozotanga kudecelerate because of the opposition. So if there is a time yainosvika maximum acceleration, yotozotanga kudecelerate because of the opposition that is coming against it due to air resistance. So ichidecelerate inozotosvika pa0. 0 iyo anosvikwa at a point where the Fw, which is its weight, is equal to the Far, which is the force as a result of air resistance. So is Fw equal to Far, then that means the resultant force is equal to 0. So kana iri 0, no acceleration. Kana pasisina acceleration, tane constant velocity, because acceleration is the change ye velocity, and it with respect to time. So zvazvinoreva manje, zvazvinoreva ndezvekuti at this point number one, forces are balanced. Number two, of course, we have said the net force, which is the force resultant, is equal to 0. Acceleration is equal to 0. Then number three, constant speed, which is equal to terminal velocity. Right, so I know we have spoken about acceleration due to gravity, but I also think it's important that we just define it. We just define acceleration due to gravity, because it's one of our objectives. If you check Panapa, we have spoken about free fall, we have spoken about terminal velocity, we have spoken about acceleration due to gravity, but we just need to also put the important notes to it. And it all right. So acceleration due to gravity is the acceleration and it let me just write this properly. Is the acceleration, right, of a free falling body caused by the Earth's gravitational pull. So pai patachitaura zve-free fall pai handiitika patati free falling objects accelerate at a constant rate. Acceleration yanenge achiita yachona iyoyo ndio inonzi acceleration due to gravity. So acceleration due to gravity inongori acceleration inenge ichiitwa nebody when the only force that is acting on it is the gravitational pull. So acceleration of free falling objects in a practical world, as it only applies in a vacuum where there is no air, which means there is no air resistance. Also, there is no other external forces are we actor pairi. So in physics, acceleration due to gravity is represented by G. So always you should know that it acts downwards. And it can. So its value near the Earth's surface, value yayo, it's 9.81 meters per second squared. But for all level questions, I'm sure 10 meters per second squared is no shanda, but the most accurate value is 9.81. So acceleration due to gravity is the same for all free falling bodies. It is the same for all free falling objects. Yakangofanana. You get it? From objects, whether it's a 500 kilogram body, whether this is a 10 grams, kana zvinhu izvi zviri in a vacuum, zviri at the same height, zvikariliswa kuti zvidzike, zvinosvikirana paground level panapa, because their acceleration yakafanana 9.81 meters per second squared, the same 9.81 meters per second squared. Right. So in now trying to accomplish the last two objectives that inadzo, which is interpret and draw velocity time graphs and attempt a few questions on motion under gravity, we are just going to use exam style questions. So I think I'll just pick two questions towards the wake up and then I think we can call it a day. So like, let us look at this question. Irikutaura pamusoro motion under gravity. So now a stone is dropped from rest. So takataura tukatongonzwa kuti rest, wotoziva kuti initial velocity yachona is 0 meters per second, right? And falls freely. Ukatongonzwa kuti free fall, wakutoziva kuti paishanda acceleration due to gravity, which is 9.81 meters per second squared. But yeah, we can use a 10 meters per second squared. And for how long? For 4 seconds. T is equal to 4 seconds. So one thing you should also know ndezvekuti even my equations of motions atakambotaura nezvawo antoshanda. Ana S is equal to ut plus half at squared. Now V is equal to U plus AT. What's the other one? S is equal to U plus V over 2 multiplied by T. Then V squared equal to U squared plus 2AS. All these apply for even in the context here, motion under gravity. So now the first question is calculate the velocity after 4 seconds, which is basically final velocity. So tofana kutarisa kuti given tukunzi titsvage v panapa handitika. So given isusu information u tinai, t tinai, a which is represented by g tinai, tukunzi titsvage v ndeipi equation inoita. If you check e haina v, so haikwanise kutipa zvatiri kutsvaga. E ina v ina u plus at zvese tinazo, so we can actually use this one. E futi haina v, e inaye v ina u ina 2as, a tinaye but s hatina, so iteketa ne2 ma-unknowns azvite. So equation inobva yaqualifier now is this one. So let us use it. V equal to u plus at. V ndio watiri kutsvaga. U wedu taona kuti ndi 0 plus at 10 multiplied by 4 seconds. So v final yedu becomes 40 meters per second. And itika sketch the velocity time graph for the motion. So one thing for sure, because this body is moving under free fall, that means in a constant acceleration of 10 meters per second, right? So graph redu v takataura kuti anoenda kupi. So kangwanyora v wako oisa SI unit yacho meters per second, t in seconds. So at 0 panapa 0 body yedu ndo pairi kutangira, and itika then after 4 seconds taona kuti 1 2 3 4 5 taona kuti yange yasvika pachi tine 10 20 30 40. So yakafamba after 4 seconds yange yasvika pana, right? So ndo velocity time graph rachona irori. Body yedu yakatanga iti 0, so it's a straight line this one because it's a constant acceleration. Our acceleration is equal to 10 meters per second squared. So ipapa patinenge tatopedza kusketcha graph rachona ndizozo. Then the other question iripo ndeyekuti use the graph to calculate the distance fallen. Takataura kuti distance yedu isusu inowanikwa by finding the area under the graph, and area yatinayo panapa, it's a triangle. Area of a triangle AT is equal to half base times height. And so our area of the triangle is half base redu rakura sei 1 2 3 4. Our height yakamira sei, which is 40. So 4 times 40, 160 divided by 2, it's 80. So 80 meters ndo distance yadonwa nedombo iri. Then the last question, state what the gradient of the graph represents. Gradient ye graph iyi inomirire chii? Inomirira acceleration. Gradient is a measure of how steep. Takati m is equal to change in y over change in x. M is equal to y2 minus y1 over x2 minus x1. So apa ndo panenge paine x2 y2, apa ndo panenge pane x1 y1. So tikatotora ma-coordinates epanapa, ma-coordinates eapa, tikati titsvage gradient using this formula, you will find kuti inotoburitsa a constant value, which is our acceleration. In this case, because it's free fall, this acceleration to represent wapai is actually g, which is acceleration due to gravity. Right. So here we have a question now that requires us to interpret the graph. Then because question yataita previously, danga ichifocus on actually sketching the graph. So now utakuita interpret a graph. I think this is our last question. Then I'll just put one for assignment that you need to look at. Naiga. So we have a graph here, a velocity time graph. Yorakidza kuti tine body yedu yakatanga iri pa 20 and it got meters per second. Then if I move for 2 seconds, yakazenge ya at 0. This is one thing you should take note. Yakazenge ya at 0. So this kuti body yatanga ine velocity high, yanga ichi decrease. This can only be explained by something chaitwa thrown upwards into the air. So pachine chaitwa thrown upwards chaiswa at a certain force, but as it goes up because of air resistance, chinenge chichidzikira acceleration ya kusvika yapa 0. Remember this question anatombo highlighta kuti is it free fall or not. So the assumption is it's operating in a real world, and mu real world mune air resistance. So kana ichikwira. So acceleration due to gravity yatachitaura nezvayo is only for free fall. But kana takutodhila nezvatakudhila nazvo right now, tichaassume kuti this is free fall. It's a real world problem. So payakandwa mudenga yatanga iri pa 20 meters per second, takakudzika ichidzika kusvika maybe apa 5 meters per second, yozosvika yabva ati pa 0. So payazosvika pa 0 apaya payatomira kuti dzi yamira ipapo. What then happened was yazotanga kudropa zvekare, chidropa zvekare ndo payazouya in negative 20. Remember this is velocity, so negative anoindicata kuti it's a change in direction, yakuenda in the direction yanga ichibva, which is why question answer, what does negative velocity indicate? It indicates kuti the body is now going in the direction opposite to its initial motion. It's now in the opposite direction. So probably this is coming back kubva pachakandwa. So describe the motion. The body or maybe the object, the body is thrown upwards. It stops, then falls downwards. That's the answer to this question. So you need to know what happened here. You also need to know what happened here. Naiga. Then calculate the acceleration. Acceleration yacho suppose acceleration takati is v minus u over t. V final at this point panapa payanga yasvika panapa tiri kuti isusu 0 because ndo final handitika minus 20 handitika meters per second, all that over 2, so it becomes negative 10 meters per second. It is negative per second squared. Negative yeyu ari kutotitaurira zvinhu zvakatokwana kutoti this was deceleration kana kuti retardation, which is why chatozombonomira. So deceleration takataura kuti negative acceleration kana kuti retardation. Then panzi isusu tofana calculate the area of the maximum height, which is basically height is a distance, and so tongotsvaga area of the triangle. So area of the triangle yedu half base redu is 2 times height 20, so area is 20 meters. Ndiyoyo area of the triangle, which is then representing the height, so it's 20 meters. Then your question, you tato explain what that means. Right, so this is the question that you're gonna do as part of your homework and assignment. Go and do it in the next video that I'll upload. I'll start by solving this question. So the next video is a question video, question and answer video. Maybe I'll be fielding my past examination style question papers, questions from question papers. What shall we then I'll post the video. I think I'll do maybe I think around 5 questions, cover the whole topic of kinematics. Then I'll post that video. I'll start by addressing this question yataisa as homework. So once again, thank you for watching. Don't forget to like, comment, share and subscribe. Please share in my colleagues so that they also learn from these videos. So thank you guys, and please don't forget to subscribe to our channel, share with everyone. Until next time.